Hey, Philip, it's good to have you on the show.
Hey, Bruce, thanks for having me. I'm going to talk about buildings in Boston, a little bit of work that we did for the city of Boston, helping them figure out how they can reduce the emissions in large buildings throughout the city. This is a project I'm really excited about because it's a really innovative policy that's going to drive down the emissions in large buildings throughout the city of Boston down to zero by year 2050. Synapse had the opportunity to support the city of Boston in developing that policy.
Sounds like the city has an ambitious goal for its buildings. Are we going to make it? And if so, how?
Yeah, it is an ambitious goal. We've seen other cities around the country and around the world put in place similar goals. And I think the thing that's unique about the Boston policy is that it actually has a stepwise plan for how to get there all the way out to 2050. Are we going to get there is a really good question, and it's a hard one to answer. There are many ways to reduce emissions from buildings: energy efficiency and electrification, end uses of energy like heating, space heating, water heating, cooking, that tend to be fossil fuel based. But if we can electrify those and get the grid cleaner, then we can drive those emissions down towards zero. There are a few types of end uses in buildings that are really hard to eliminate the emissions from, such as backup generators that you need for ensuring that hospitals can still run when the grid is out, and some process loads in labs and other science buildings that historically have been run by fossil fuels and are just really hard to change over. But we had the opportunity to dive into all of that in the project for the city of Boston. So it was pretty interesting work.
Cool. You know, show us the data on the buildings?
Yeah, what you're seeing here is a plot that we did towards the beginning of the project to try and understand where the emissions are coming from. So what you see here is a figure with about 1,600 little bars, and each bar represents a building. And on the vertical axis, we have the emissions intensity in kilograms of CO2 per square foot per year. So that tells you how intensive the energy use and therefore emissions in the building are. And then on the horizontal axis, we have the floor area of the buildings. If you think of each building as a rectangle, the height of it is how intensive it is in terms of emissions, and the width of it is its floor area. So the actual area of that rectangle is its total emissions. And then what I've done is I have grouped them together by the type of building. So we've developed 13 different typologies that are relevant to Boston buildings. And you see all of these bars organized and color-coded by the different type of building. What this shows us is that different types of buildings tend to have different emissions intensity profiles. And within the various groups of buildings, there are some buildings that perform really well, that have pretty low emissions intensities. And there are some buildings that have really high emissions intensities. And this policy is an opportunity to drive down the emissions across the entire profile, and starting with the buildings that are the poorest performing, that have the most emissions over time. So this plot that we did helps us to understand where the emissions come from, what are the primary sources of emissions throughout Boston, and where the city should be focusing its efforts.
The plot almost turns this challenge with regard to buildings into a video game where you're pushing down the higher bars, and the objective is to reduce the area of the CO2, right?
Yeah, that's exactly it. And there's a bunch of different ways you could do that, a bunch of different policy levers you could pull. And we looked at a couple of them. And I have sort of a corollary to this plot, another plot that shows if the city were to set firm emissions thresholds for each of the different building types that get more stringent over time, what would be the impact on individual buildings and the overall portfolio of buildings emissions over time? So think of it as kind of the gamification, sort of slicing the emissions and driving it towards zero over time. And this figure shows you which buildings need to improve and by how much over these 5-year milestones that the city is looking at establishing, all the way out to 2050, which gets us down to zero emissions.
Can you take this into the future in terms of what's going to happen next to these buildings?
Yeah, right. So the thought is that by year 2025, the first step of the policy would go into place. And so these buildings that have been reporting their energy to the city of Boston over time would actually need to make some actions to improve their emissions profiles. And that looks like energy efficiency upgrades, going into the buildings and upgrading the lights to be more energy efficient. Maybe that's going from fluorescent fixtures, incandescent light bulbs, metal halide, high intensity discharge, all these disparate lighting technologies and switching them all out to be LEDs. Maybe it's upgrading the envelope, the shell of the building, adding insulation and sealing air gaps, maybe changing out windows, that sort of work to make the envelope of the building a lot tighter and better insulated. Those types of energy efficiency measures will get the buildings to reduce their energy use and drive down their emissions over time. And then at some point, as these thresholds get lower and lower over time and the buildings have to reduce their emissions really dramatically, at some point, these buildings are going to need to move away from fossil fuels. So as we look out to the years, maybe 2035, 2040, 2045, they're going to have to make some changes that maybe means taking their existing boilers that heat the building and converting those boilers over to heat pumps that extract heat from the out of doors, from the ground, and pump it into the building using electricity as opposed to burning natural gas to heat the buildings. So this does give us a little bit of a glimpse into how much the buildings need to improve. And we've also done some work to evaluate those different pathways and what will be the best technologies, the most cost-effective technologies to get there.
To meet this aggressive goal for building decarbonization, it seems like you can't really just wait till the last few years and then do all the electrification of the HVAC, right? So it's got to be some phasing. And just as the targets phase in over time, it seems like the electrification piece of this also probably should get started right away, right? Then develop over this period.
Yeah, absolutely. Right. So for a lot of these buildings, when we talk about HVAC systems in commercial buildings and multifamily buildings, they tend to have pretty long lifespans. Depending on the equipment, it could be in the range of 20 to 30 years. And for most buildings, we just have one shot between now and 2050. So based on our economic analysis, our findings are that the most cost-effective way to electrify a building is to wait until the system is nearing the end of its useful life and to change over the system at that time. So if you have a building that has an older boiler that's going to need to be replaced in the next couple of years, you don't want to change it out with another boiler at this point. Knowing that the policy is going to require you to drive your emissions down to zero by 2050, you want to go ahead and change it out to a heat pump, electrify that end use as soon as that system is approaching the end of its useful life. So we've actually done some case studies. We've zoomed in on individual buildings in this portfolio and spent some time evaluating what their existing equipment systems are, when we expect them to near the end of their useful life, and what measures they would need to take in that building to get it down to zero emissions by 2050, and sort of a phased approach to electrification and energy efficiency retrofits.
So if a building gets out ahead of the standard by reducing its emissions more rapidly or beyond the standard through, say, electrification before it would be, quote, necessary, do they get some kind of credit for that in the policy? Or is it just hey, you're saving fossil fuels and carbon emissions?
So there is a benefit that you noted, saving fossil fuel and carbon emissions, but also a cost savings benefit. In many cases, these energy efficiency measures are going to be net positive cash flow. They're going to save more in energy costs than it's going to cost to install them. That's not always the case with electrification at today's prices and without something like a federal carbon tax or cap and trade policy. So there are benefits in terms of economics of getting ahead of the curve. And we helped the city do a little bit of an evaluation, looking at some case studies from around the world for cities that have put in place a sort of cap and trade or market-based system for how buildings that can get ahead of the curve could sort of bank those emissions credits and sell them to other buildings that are maybe harder to electrify, harder to decarbonize. So we did an evaluation of that, and the city is considering what they're calling an alternative compliance payment. That could be a way to shift emissions from one set of buildings to another set of buildings, those that are able to get ahead of the curve to those that are maybe struggling to do so. The other approach that can be used is purchasing off-site renewables that meet some sort of qualified criteria to ensure that those renewables are certified and of good credibility, that meet stringent qualifications that ensure that the project that was funded by that purchase is additional, that it's actually creating new benefit to the grid by displacing fossil-based generation. And so buildings have the opportunity to purchase offsite renewable energy to help drive down their emissions over time.
Yeah, so what you mean to say is that these recs aren't bogus and create a loophole that undermines the whole objective of the program, right?
You got it. We don't want any loopholes. We want these buildings to actually make a change and a net impact that's for the best.
Well, and by the time you get out to 2040 and 2050, it feels like all of the offsets and offsite rate, like all of that's going to be needed for reducing carbon. So it's not like there's a lot of extra reductions around to somehow buy your way out of actual reductions.
That's exactly it. If we as a society are going to meet the thresholds and the targets that we know based on science to avoid some of the worst impacts of climate change, we're going to need every tool in the toolkit. You know, we talk about it not as the silver bullet, but the silver buckshot. It's energy efficiency in buildings, it's electrification of end uses, it's on-site and off-site renewable energy purchase. It's everything in the toolkit.
If other cities want to do something that's resembling this awesome work that the city of Boston is doing, who should they call?
Well, absolutely, they should call Synapse. We love this type of work. We're competent at it. We've got a really great team. And I would just say a lot of thanks to my colleagues who assisted with this project. We had a really great project team. Asa Hopkins, Kenji Takahashi, Danielle Goldberg, and Shelley Kwok. We had a really great project team with a lot of competent energy professionals across the spectrum of building science and grid-based solutions. Bruce, I would also suggest that other cities interested in this type of policy reach out to the city of Boston, because the city of Boston is really leading the way in energy efficiency and climate policy and a whole range of energy-related policies, and to drive down their emissions citywide. That's for buildings, as we've been discussing today, as well as a whole range of other end uses. You know, buildings account for 75% of the carbon emissions in the city of Boston, but the city also has some innovative strategies for other end uses and other sectors. I also would like to just say our great appreciation for the technical advisory group. It was a team of about 50 energy and sustainability and climate and construction, architecture, engineering professionals that got together and supported the city and supported Synapse through all of our analysis. And they helped us to develop these thresholds, to think through the policy, its impact on actual buildings, the impacts on those who live in the buildings and the owners of the buildings. So we had a really incredible technical advisory group that helped us to prepare the analysis and help to develop the policy.
And if anyone watching the show wants to read the report or learn more about the details of the process or the analysis or the policies, is the report available?
Yeah, so the City of Boston is going to be publishing the report and all of the slide decks from all of our technical advisory group meetings on their website. That will be happening in the next month or so. We can link to that. We certainly will have a spot on the Synapse website that we can point interested cities and other viewers to check that out.
Great. Thanks, Philip. Thanks for all this awesome work and for being on the show.
Yeah, my pleasure. Thanks for having me.
See ya.
Bye.
Thanks for watching. This is Energy Nerd Show and Tell.
It's the show that we want to watch, so we're thinking maybe some of you energy nerds want to watch it too. If you do, then hey, tell your friends and subscribe right around here. Click there.
And check
or there. Or over here.
Instagram and Twitter and Facebook and YouTube and where else?
Yeah, and the Energy Nerd website at energynerdshow.com. You can always go there. And if you want to be a guest, you can volunteer to be a guest. We love to have guests. In fact, that's kind of what the show is all about.
Absolutely.